VOM, which stands for volt ohm milliammeter, is an essential tool for anyone working with electronics or electrical circuits. It measures three fundamental electrical parameters: voltage, resistance, and current. Firstly, voltage is the electrical potential difference between 2 points in a circuit. It's the driving force that pushes electrons through the circuit. Voltage is measured in volts. Think of voltage as the pressure in a water pipe. The higher the pressure, the more water flows. Similarly, the higher the voltage, the more current flows through a circuit, assuming the resistance remains constant. A VOM measures voltage by connecting its probes to 2 points in the circuit. The meter then displays the potential difference between those 2 points. There are two types of voltage measurements: alternating current voltage and direct current voltage. Alternating current voltage constantly changes direction, while direct current voltage flows in one direction only. Batteries typically supply direct current voltage, while household outlets supply alternating current voltage. Secondly, resistance is the opposition to the flow of electric current. It is measured in ohms. Every material offers some resistance to the flow of current. Materials that offer very little resistance, like copper and silver, are called conductors. Materials that offer a lot of resistance, like rubber and glass, are called insulators. Resistance is like a valve in a water pipe. The more the valve is closed, the less water flows. Similarly, the higher the resistance in a circuit, the less current flows, assuming the voltage remains constant. A VOM measures resistance by applying a small voltage to the component being tested and measuring the resulting current. Using Ohm's law, resistance equals voltage divided by current. The meter calculates and displays the resistance value. It's important to disconnect the component from the circuit before measuring its resistance to avoid inaccurate readings. When measuring resistance, you are essentially checking the integrity of a component or a circuit path. A very high resistance reading where you expect a lower resistance could indicate a broken wire or a faulty component. A very low resistance reading where you expect a higher resistance could indicate a short circuit. Thirdly, current is the flow of electric charge through a conductor. It's measured in amps. Current is like the amount of water flowing through a pipe. The more water that flows, the higher the current. Similarly, the more electrons that flow through a circuit, the higher the current. A VOM measures current by connecting it in series with the circuit. This means the current must flow through the meter for it to be measured. Unlike voltage measurements where you connect the probes across 2 points, current measurements require you to break the circuit and insert the meter in the path of the current. This allows the meter to measure the amount of charge flowing through it. Measuring current can be more delicate than measuring voltage or resistance, because if you select the wrong range or connect the meter incorrectly, you can blow a fuse inside the VOM or even damage the meter itself. Always start with the highest current range and work your way down to get an accurate reading without overloading the meter. Using a VOM effectively involves understanding the different settings and ranges available. Most VOM have a rotary switch that allows you to select the type of measurement you want to make, such as alternating current voltage, direct current voltage, resistance, direct current amperage, or alternating current amperage. Each setting also has multiple ranges. These ranges determine the maximum value the meter can display. For example, if you're measuring a voltage you expect to be around 12 volts, you would select a direct current voltage range that is higher than 12 volts, such as 20 volts. This ensures the meter can accurately display the voltage without being overloaded. If you're unsure of the voltage, start with the highest range and work your way down until you get a good reading. Another important aspect of using a VOM is understanding the different types of probes and leads. Most VOM come with a set of standard probes, one red and one black. The red probe is typically used for positive connections, while the black probe is used for negative or ground connections. When measuring voltage, it's important to connect the probes with the correct polarity. Connecting them backwards won't damage the meter in most cases, but it will result in a negative reading. When measuring resistance or current, polarity doesn't matter. In addition to standard probes, there are also various specialized probes and leads available for different applications. For example, there are alligator clips that can be used to connect the meter to wires or components without having to hold the probes in place. There are also temperature probes that can be used to measure temperature. When using a VOM, it's important to follow some basic safety precautions. Firstly, always disconnect the power from the circuit before making any measurements. This will prevent electric shock. Secondly, never touch the metal parts of the probes while the meter is connected to a live circuit. Thirdly, always use the correct range setting. Using too low of a range can damage the meter. Fourthly, inspect the probes and leads for any damage before using them. Damaged probes or leads can be a safety hazard. Fifthly, be aware of your surroundings and avoid working in wet or damp conditions. Water can conduct electricity and increase the risk of electric shock. Besides measuring voltage, resistance, and current, some VOM also have additional features, such as the ability to measure capacitance, frequency, and temperature. Capacitance is the ability of a component to store an electrical charge. It is measured in farads. Capacitors are used in circuits to filter signals, store energy, and provide timing functions. A VOM with a capacitance measurement function can be used to check the value of a capacitor or to identify faulty capacitors. Frequency is the number of times a signal repeats itself per second. It is measured in hertz. Frequency is an important parameter in alternating current circuits. A VOM with a frequency measurement function can be used to measure the frequency of a signal or to troubleshoot problems with alternating current circuits. Temperature is a measure of the hotness or coldness of an object. It is measured in degrees Celsius or Fahrenheit. A VOM with a temperature measurement function can be used to measure the temperature of components or circuits. This can be useful for troubleshooting overheating problems. Understanding the internal workings of a VOM can also be helpful in troubleshooting problems. A VOM typically consists of several key components, including a display, a rotary switch, a set of probes, a battery, and a circuit board. The display shows the measurement results. It can be an analog display with a needle or a digital display with numbers. Digital displays are generally more accurate and easier to read than analog displays. The rotary switch allows you to select the type of measurement you want to make and the range. The probes are used to connect the meter to the circuit being tested. The battery provides power to the meter. The circuit board contains the electronic components that perform the measurements. When a VOM malfunctions, it's often due to a problem with one of these components. For example, the battery may be dead, the probes may be damaged, or the circuit board may be faulty. In some cases, it may be possible to repair the VOM by replacing the faulty component. However, in other cases, it may be more cost-effective to simply replace the entire meter. Using a VOM is a fundamental skill for anyone working with electronics or electrical circuits. By understanding the basics of voltage, resistance, and current, and by following some basic safety precautions, you can use a VOM to troubleshoot problems, diagnose faults, and make accurate measurements. Always remember to consult the VOM user manual for specific instructions and safety guidelines. When measuring voltage, consider the voltage rating of the VOM. Never attempt to measure voltages higher than the VOM maximum rating, as this can damage the meter and pose a safety hazard. VOM are rated for both alternating current and direct current voltage. Be sure to select the appropriate setting. When measuring resistance, ensure the circuit is de-energized. Measuring resistance in a live circuit can damage the VOM and provide inaccurate readings. Resistance measurements are most accurate when the component being tested is isolated from the rest of the circuit. When measuring current, select the appropriate current range in the VOM. Starting with the highest range and working your way down is a good practice. Exceeding the VOM current rating can blow the internal fuse or damage the meter. Pay attention to the polarity when measuring direct current voltage or current. Connecting the probes with the wrong polarity can result in a negative reading or damage to the VOM. Many VOM have a built-in continuity tester. This feature is useful for checking for broken wires or faulty connections. The continuity tester emits a beep when there is a continuous path between the probes. VOM can be used to test a variety of components, including resistors, capacitors, diodes, and transistors. Each component requires a specific testing procedure. Consult the VOM user manual or a reliable electronics resource for guidance. When working with high voltage circuits, always take extra precautions. Wear appropriate safety gear such as insulated gloves and eye protection. Be aware of your surroundings and avoid touching any exposed wires or terminals. VOM are sensitive instruments. Handle them with care to avoid damage. Store them in a safe place when not in use. Regularly check the VOM battery. A low battery can cause inaccurate readings. Replace the battery as needed. Cleaning the VOM regularly can help keep it in good working condition. Use a soft cloth to wipe away any dirt or debris. Avoid using harsh chemicals or solvents. Calibrating your VOM regularly will help ensure accurate measurements. The calibration process varies depending on the model of VOM. Consult the user manual for instructions. In addition to VOM, there are other types of multimeters available, such as clamp meters and digital multimeters. Clamp meters are used to measure current without having to break the circuit. Digital multimeters offer a variety of advanced features, such as auto-ranging and data logging. Choosing the right type of multimeter depends on your specific needs. The accuracy of a VOM is typically expressed as a percentage of the reading. For example, a VOM with an accuracy of plus or minus 1% will have a maximum error of 1% of the reading. When making critical measurements, it is important to use a VOM with a high level of accuracy. The resolution of a VOM is the smallest increment that it can display. For example, a VOM with a resolution of 0.1 volts can display voltage readings to the nearest thousandth of a volt. A higher resolution is desirable for making precise measurements. The input impedance of a VOM is the resistance that it presents to the circuit being tested. A high input impedance is desirable because it minimizes the loading effect on the circuit. The loading effect occurs when the VOM draws current from the circuit, which can alter the voltage being measured. Some VOM have a built-in backlight, which can be helpful when working in low light conditions. Other features to look for in a VOM include a data hold function, a min-max recording function, and an auto power-off function. The data hold function allows you to freeze the reading on the display. The min-max recording function records the minimum and maximum values of a signal. The auto power-off function automatically turns off the VOM after a period of inactivity, which helps to conserve battery power. When purchasing a VOM, it is important to consider your budget, your needs, and the features that are most important to you. There are many different VOM available on the market, so it is important to do your research and choose one that is right for you. By understanding the principles of voltage, resistance, and current, and by using a VOM correctly and safely, you can troubleshoot electrical problems, diagnose faults, and make accurate measurements.